I want to talk about performance analysis of quantum machine learning classifiers. This is my team, Olajuela Tonidas, Pablo Rivas, and myself, Javier Orduz. And I want to talk about this topic. In this document, we mix two important fields: physics and artificial intelligence. From physics, we take quantum mechanics, and from artificial intelligence, we take machine learning. The main idea with this work is take two data sets and explore the behavior of the quantum classifiers. Those data sets should be linearly and non-linearly separable. We want to to show the analytical results of the four quantum classifiers, and in terms of times and accuracy. Then here we show the different classifiers that we are going to use to do our analysis, which are support vector classification with quantum kernel, or SBCQK, quantum support vector classifier, or QSBC, variational quantum classifier BQC, and circuit quantum neural network classifier CQNNC. In this figure, we show the data sets, and in A, B, C, and D plots, we can see that we have linearly and non-linearly separable data sets. About the methodology, we choose those algorithms or classifiers that I mentioned before, and also we are going to use one model in Python, which is Qiskit, and there we besides used scikit-learn and matplotlib. But in this table shows the performance of the four algorithms for the different data sets that we showed before, and in terms of the results are shows in terms of time as training time, predict time, and accuracy for each algorithm. Okay, about the results, we found that those algorithms, which are SBCQK, QSBC, and CQNNC, provide equivalent accuracy for both datasets. On the other hand, BQC performs poorly in terms of accuracy. Besides, we found that the two algorithms, those is SBCQK and QSBC, require identical training and testing times, but BQC and CQNNC require slightly more training time for smaller datasets. Okay, finally, we want to mention that BQC algorithm has some peculiarities as a classifier or quantum classifier. We want to mention that this work was partially supported by Baylor AI, Baylor University, and also we want to share our material PDF and Jupyter Notebook.
Why did you choose this particular model in your case for all the authors? And is this an initial test? I guess that is for the last speaker.
Hi there. I can take a stab at the question. In our case of this is Pablo Rivas. In the case of the classifiers related to quantum computing and the tests we're doing, these are preliminary results, and these are initial attempts to quantify and measure some of the practical currently how practical it is for students or research teams to invest time in classifiers that are based on quantum computing theory. And yeah, the results are all right. We're making a lot of progress in quantum computing, and I feel positive that we're gonna keep having better and better applications of it really soon.